In this video, we're going to be talking about interpreting quadratic functions using a graph now. So we should be following along with our worksheet as I go through this so that you can fill in the examples throughout the video. In example 1, we've got Alice jumped off a cliff and landed on the ground below. We can represent her jump with the equation y equals negative x squared plus 6x plus 5. Part A is just having us fill out the table for the x values of 0, 2, 4, and 6. So again, we're just going to substitute those x values in. Notice when we substitute the x values in, no matter what the x values are, we are including them inside a set of brackets because we want to make sure that negative is outside of our squared value. Then we should get the answers of 5, 13, 13, and 5 for our y values for the x's that are given. Moving on to part B, we've got graph the function now. So we're going to use our table of values that we just found to help graph that. So we're going to have a coordinate at 0, 5, and then 2, 13, 4, 13, and 6, 5. The last step is just simply draw a line through your points. Remember that they will actually go past those points at the top because you won't just draw a line across making it flat. It needs to be a curved top. And in this case, it actually goes up to the value of 14. And then also make sure you only used curved lines. Part C of this example now wants us to figure out how high the cliff is above the ground level. So that is her starting position, meaning it's 0 seconds into her jump. So we're going to look at where the x value is 0. And as you can see, it's crossing at 5, so it's about 5 meters above the ground level. Part D of this example wants us to figure out how high off the ground level did she reach on her jump. So that's really just saying what's the maximum point, and it's going to be the y value for that maximum point. So as you can see, we can go over and see that that y value that is going to be 14 meters. Part E of this example, we want to know how many seconds did it take for her to land on ground level. So when she's landing on ground level, the graph will be at the x-axis. So really we're saying from 0 until where the line is crossing the x-axis again. And this is approximately 7 seconds. For part F of this example, we want to know how many seconds after her jump did she reach her maximum height. Now with this, we're going to check the x value of the maximum point now, because this one is the one that represents time. So as we can see, it's going to be at an x value of 3, so it's 3 seconds. Moving on to example 2, we've got Hannah is watering her garden. The water coming from the hose pipe forms a smooth curve, which is represented by this graph. Part A is what's the maximum height that the water has reached. This is again just going to be at that maximum point of our graph, which as we look over, we can see it's at 2 meters. In part B of this example, we want to know how long did the water take to hit the ground after leaving the hose pipe. Remember that returning to the ground is when it crosses the x-axis, and we can see that it goes from 0 until about 2.1, so it's roughly 2.1 seconds. Part C of this example is asking for the practical meaning of the starting point of the graph. This question is just saying, what does that starting point represent in terms of this problem? So in this case, the starting point is representing the height before the water actually leaves the hose pipe. In part D of this example, we want to know the height of the water after 2 seconds. So what you can do is say, well, 2 seconds is a value on the x-axis, so we're going to go from the 2 up until we hit our line. Then from there, it's just a matter of figuring out what the y value is at that part on the line. And in this case, it's about 0.3 meters. That's all for this video. If you have any questions, then just leave a comment on Show My Homework, and I will get back to you as soon as I can. Thanks.